Okay, we've got one issue that came up, and maybe I'll just kind of show it to you here first. My intention was to get the shaft that's going to go down the middle of this ball as a nice tight fit. And I ordered the shaft, very specific, and it turns out that it came to me a little bit undersized. So the shaft tends to just slide down instead of a good tight fit. So what I'm going to do is I'm going to move this over just a few degrees. Just come in. Oh, actually, let me do it on another one. Move it over just a few degrees. Bring it in closer so I know I'm there. And literally just kind of right at the edge of the magnet. And then I'm going to drill to the center hole. And then put run a tap in there and just snug down the shaft just a little bit. I think I'm going to have to center drill this first though. Okay, in order to set the drill head up, we're going to have to back this thing way up, which, we don't have room to back it way up. Now that was something I wasn't counting on. Okay. Well, I know what we can do is we can put a collet in there, and I've got some pretty small collets with the drill bit that'll fit in that, and then so the collet will be in there, and we'll have just the drill bit, and it'll run just fine. We'll put ourselves a little center drill in here. Let's see, it's probably going to take. Is it going to be this one? Yeah, there we go. Loosen things up. Pull out the collet. Nice thing about this 90-degree head is it uses standard collets, which means I don't have to mess around with a bunch of collets. That's set. Okay, come back to 0. Well, just 0 on the closest one. Looks like a plan. Oops. So we've got the flats cut, we've got the pilot set, and now we've gone in and we're drilling the holes. And let me pull you in a little closer here. And you can see the drill is set up and ready to go. We're going to turn it on and drill a hole for you. And I've got a little mark on the drill bit right there. You probably can't see it, but I've got that mark there. But I also go with the digital readout, so that kind of gives me a more accurate view of how deep I've gone. So I don't go too deep, or I don't go too shallow. So we got about another 20 or 30 thousandths to go. And we're set. down to 6,000. There we go, almost there. 0. We'll back up a little bit. And the rotary table gets rotated once again. Release. Run it around 45 degrees. Almost to the mark. Bring it up to 0 on the minutes. And we're ready to go. And start drilling. Let's put a little bit of oil on that. We'll come back in a little closer here. 130, 110, 70,000, so we're just cranking out the drilling. Down to 7,430. Back it up. And do it again. We're going to save you the boring moments of going around this circle. Okay, we've got one issue that came up, and maybe I'll just kind of show it to you here first. My intention was to get the shaft that's going to go down the middle of this ball as a nice tight fit. And I ordered the shaft, very specific, and it turns out that it came to me a little bit undersized, so the shaft tends to just slide down instead of a good tight fit. So what I'm going to do is I'm going to move this over just a few degrees. Just come in, oh actually let me do it on another one. Move it over just a few degrees, bring it in closer so I know I'm there. And literally just kind of right at the edge of the magnet. And then I'm going to drill to the center hole and then put run a tap in there and just snug down the shaft just a little bit. I think I'm going to have to center drill this first though. Cut a hole in the ball or in the sphere all the way to the center core, and now we're going to set a set screw in there. But first we got to figure out what our size is, and sometimes I'll take measurements and figure out what the thread is and go through all that rigmarole. But other times I'll just come in and go, okay, take my vernier calipers and go in between the threads, grab it fairly tight, and lock it down, and then pull that out, and that's pretty much my smaller diameter of the threads. So you know, and then if I'm doing a real tight thing, then I definitely do all the calculations and all that. But in this case, we're just talking about a set screw that's really not going to be cranked down that hard. So basically, I've got my inside thread measurement, and I go find a drill bit that fits that gap. Now, in this case, I'm going to need to also do a countersink, because the hole that this is going to go into, this is about, what, ½ an inch long or so, and the hole that it's going to go into is about 2 or 3 inches long. Well, no, it's 3.5, so 1.5 inches long. So there's going to be a long thread that I have to do, and I don't have a tap that is going to thread that as readily. So what I'll do is take the outside measurement and find a drill bit that fits the outside measurement and drill the hole down, most of the way, and then the final distance will be threadable. Okay, so going in with a little bit larger drill bit, and this is the minor diameter for the threads, and we're just going to take that all the way in. It's going to go pretty easy, all the way in until it punches through into the center hole, and should go through any second. There it goes. Done deal. Now we jump up to the larger diameter, which is going to be the outside of the threads of the set screw. And we'll turn you off for a moment. Okay, we got the larger diameter bit in, and we're really just going to go in about halfway up this shank. So I'm going to draw a little line so I don't end up going too far. And that's just going to relieve it just enough so we can get a tap in there. And that's going to go pretty fast, as you can see. We're there already. Done deal. Put a tap in there, and we'll call it a day. Now the other thing is that we're going to tap each one of these little holes. You know, I was going to use the drill head to do that, but you know, basically it's not a real accurate hole, nor is it, you know, it's just a screw going in, so I can pretty much just do it by hand. This wants to be a little bit more accurate, so I'm going to slide it. No, actually, I can just slide a tap in there now that I think of it. It'll hold just fine. All right. A little air. Let's blow out this thing. We still have to come down into the hole with the reamer one more time and kind of clean out the flashing that comes out of when you push the drill through. There's always a little bit of mushrooming that happens. But so far, we're going to come in here and tap that hole and put the set screw in and see what we got. Okay, so we're at the point now to where we're going to tap the little holes in the center to hold the magnets, and that's a pretty simple deal. Basically, we just run the tap in. If it feels a little bit too stiff, then back it up a little bit and give it a, let it break the chips. Running it in. Doesn't seem like it's going in that easy though. Yeah, that's it. Shit. So we had a couple of disasters happen here in the last couple of days with this thing, and I'm going to break it loose here, and we'll spin it around. What's happened was is I built the thing, cut these holes, and then went into this small, cut these pockets, and then went into this small hole and drilled that out, and went to tap it, and broke off the tap inside of the hole. Oh man, what a disaster. So then I had to go in and dig out the tap, which was not so bad because I could just do all the digging right inside of this 3/4 pocket here, and I just went in and milled out around the tap, and then broke the tap out, and then went back in and took my mill and went all the way in with the mill, kind of like a drill, and then put plugs in, or a plug. But what happened was the next day I went in and I broke a second tap off. I couldn't believe it. I was being careful and everything, and it broke off. So I had to do it twice. And then, same thing happened a third time. I didn't break a tap off, but what happened is that one hole that I drilled that went all the way through into the shaft, so it would hold the shaft tight, that hole broke through into the drilled hole. What a mess. So I had to go in and do this, put 3 plugs in and set them, and then press them in, and then reset this up on the rotary table. And now I'm going to go in and drill these plugs out so that they are, equal and very similar to these plugs. So then once I get that all done, I re-drill them, re-tap them, get everything set, and hopefully I'm in good shape. Then come up, and I'm going to pull back here. We're going to reset the head of the mill so that it rotates at a 45-degree angle, and actually, yes, it'll go that way. So this head rotates. This drill bit that comes out, or it's actually a mill bit that will come out, will be at a 45-degree angle, and it'll come in and point at the ball at a 45-degree angle. Then my guy wants me to cut 8 more of these around the perimeter at a 45, and then one more time come back in and do it a second time at the bottom. So rotate the head the other way 45 degrees, have the mill bit come up and point into it like that, and then cut those flats and drill them, tap them, and put magnets in them. Then we're pretty well done with that part. It's a long process, and yet I really enjoy doing it because it's got a lot of complicated angles, and I have to kind of work out a lot of complicated processes, especially since I broke off the taps in those holes. So we're going to do a little bit more machine work, and we will be back in a minute or an hour or a day.